Justice has always leaned on fragile testimony, fading photographs, and the slow decay of physical evidence. But what if the most reliable witness was not a person at all, but the silent architecture of the brain itself? This is neural forensics, the decoding of residual memory traces from preserved neural tissue. By extracting dormant synaptic patterns, investigators can reconstruct crime scenes long after traditional evidence has vanished. In this haunting frontier, the skull becomes a crystalline archive, whispering truths that neither time nor silence can erase. In 1996, the "Silent Basement" case baffled investigators. DNA degraded, witnesses contradicted themselves, and the crime remained unsolved for 30 years. But in 2026, a breakthrough in neuropreservation allowed researchers to stabilize hippocampal tissue from the victim. Unlike testimony, which bends under distortion, synaptic echoes offered direct sensory data. For the first time, investigators weren't asking what a witness remembered, they were downloading the electrical imprint of the event itself. Trauma leaves scars deeper than ordinary experience. High-stress events embed chemically distinct hard writes into neural architecture, fragments that resist time. Neural forensics exploits this resilience. By mapping residual patterns in preserved tissue, scientists distinguish between subjective storytelling and objective biological record. The hippocampus, long known as the seat of memory, becomes a forensic vault, its echoes immune to bias. The process is as eerie as it is revolutionary. Through synaptic slicing, AI systems reconstruct three-dimensional environments from fragmented neural pulses. Dreams and imagination are filtered out, isolating the precise timestamp of the crime. In 2026, legal frameworks began to classify these reconstructions as admissible evidence. Could a decaying brain truly testify? And if so, who owns the rights to its silent memories? The Silent Basement case reached its turning point when researchers rendered a visual reconstruction of the crime scene from the victim's preserved hippocampus. The biomap aligned chillingly with original police photographs, but revealed one detail absent from the files: the killer's face, frozen in the victim's final sensory imprint. The crystalline witness had spoken, not through words, but through the architecture of memory itself. Justice, delayed for decades, emerged from the graveyard of synapses. Yet the implications are unsettling. If the skull's silent architecture can no longer keep secrets, does privacy survive death? Neural forensics is already being explored to exonerate the wrongfully convicted, scanning their own residual memories for proof of innocence. But the same technology raises profound questions. Should investigators exhume minds as they exhume bodies? Is justice worth violating the final sanctuary of human privacy? Neural forensics transforms decaying biological matter into crystalline testimony, offering hope for cold cases and justice long denied. But it also forces us to confront a haunting dilemma: when the dead can speak through their biology, are we honoring their truth, or trespassing into their last refuge? The future of crime solving may lie not in fingerprints or DNA, but in the echoes of memory itself. And in those echoes, justice may finally awaken.